Hi everybody, Mrs. Pesic here,
And Miss Bella here.
and we're looking at section 6.5, operations with functions, and your objectives today are to add, subtract, multiply, and divide functions, and to be able to write and evaluate composite functions. And the new vocabulary for this section is composition of the functions.
So you can perform operations on functions in much the same way that you can perform operations on numbers or expressions. So we can add, subtract, multiply, or divide by operating on their rules. So just a little bit of notation here. Again, we have addition of f plus g of x, which would just mean to add the two functions. We can subtract them, multiply, or divide. Again, most important thing here to point out is that you must make sure the denominator cannot equal 0, because that would be dividing by something that would be undefined. So our first example here, we are going to jump right into adding and subtracting. So given f of x equals 4x squared plus 3x minus 1 and g of x equals 6x plus 2, we're going to find each function. So I'm going to start you off with the first one here, f plus g of x. So this really means take the function f of x and add it to the function g of x. So we will have 4x squared plus 3x minus 1, there's f, and I'm going to add to this the function g, which is 6x plus 2. Now, notice that really this is just like a 1 out here, so I don't need to distribute. So I just have to combine my like terms. So I'm going to get rid of the parentheses here for a second. And combining like terms in standard form, my only x squared term, my linear term would be 3x plus 6x or plus 9x. And then my constants, -1 plus 2, will end up with a positive 1 at the end there. So f plus g of x is 4x squared plus 9x plus 1.
Okay, and if we take those same two functions and we do subtraction with them, we can say this is really saying f of x minus g of x. And so we want to take f of x, which is 4x squared plus 3x minus 1, and we're going to subtract from that the g function, which is 6x plus 2. And in this case, you could think of this as like a -1 out here, and then we want to distribute that -1. So we really have 4x squared plus 3x minus 1 minus 6x minus 2. Don't forget to distribute that -1. And again, if we clean up like terms, we only have one x squared term, so that's 4x squared. We've got a 3x and a minus 6x, which would be a minus 3x. And then we have the -1 and a -2, which would be a minus 3. So this would be our answer for f minus g of x.
So this takes you to your first must-do. So given f of x and g of x, I always do the highlighter there. All right, f of x and g of x, nope, there you go. Go ahead and find the addition of those, f plus g of x, and then the subtraction, f minus g of x. Remember to distribute your negative when you do the subtraction there. Okay, next up, we're going to look at some multiplying and dividing. Just a little note there of caution. When you divide functions, be sure to note any domain restrictions that may arise. So when you do the division, anything that would make the denominator equal to 0, you must rule out. All right, first up, we're going to multiply. Again, f g of x really means f of x multiplied by g of x. That's our notation, right? There's like a multiplication symbol between those. So I'm going to take 6x squared minus x minus 12, and I'm going to multiply it by 2x minus 3. Now, some of you might prefer to distribute through this. I'm going to set up the box method here, because I think that that's kind of a way that some of us have demonstrated that we like doing this a little bit better.
The box rocks.
Oh, the box rocks. All right. 6x squared minus x minus 12 along this side. And then across the top here, I'll have a 2x minus 3. All right, so if I'm going to multiply, remember when doing the box method, I want to multiply what would be the column and the row for each box. So this will become 12x to the third minus 18x squared minus 2x squared plus 3x, watch your sign there, minus 24x plus 36. Remember, my last step in the box method is then to combine like terms. So the only cubic term would be 12x to the third. My quadratics here with x squared minus 2x and a minus 18x squared for both of those, excuse me, minus 20x squared. My linear terms, and minus 24x plus 3x, so I'll have a minus 21x, and then finally my constant bringing that down will be plus 36. So this is the product, or what you get from multiplying f times g.
Okay, and then if we are going to divide f divided by g of x, we would have to take remember this means f of x divided by g of x. So we're taking one function divided by the other. So if we have 6x squared minus x minus 12, and we're dividing by 2x minus 3, this could be your answer for this problem. I suppose we could do long division on this, but let's not. And then if we do want to say what the x value cannot equal, so x cannot equal what in this? Well, we can't have 2x minus 3 equaling 0, so let's solve that equation. Let's add 3 to both sides. We get 2x equals 3. Divide by 2, we get x equals 3 halves. So that's the value that has to get tossed out of the domain. So our answer is here, and x cannot equal 3 halves. Did?
Yeah, I did. I mean, really, this one does factor, but we could, if we do product sum on the top, it would have become 2x minus 3 times the quantity of 3x plus 4.
Oh, and look at that. The 2x minus 3's divide out. So really, it would be equal to 3x plus 4, but don't forget, x cannot equal 3 halves.
Right, you would still need that restriction there because it was in the denominator at one point. Okay, so that's kind of just our add, subtract, multiply, and divide. So the next part of this section is about composition. So here's that vocab word we had. Another function operation uses the output from one function as the input for a second function. So it's the answer you get from one, you use as a number you plug in for another. So this operation is called the composition of functions. So here's some notation from the book on what this looks like. Again, when we use composition, we're going to use this new symbol, which is kind of like a little circle here in the middle. And another way to write that is kind of like a nested function where we have g of x inside f of x. The domain of f of g of x is the values of x in the domain of g such that g of x is in the domain of f. Again, that's kind of wordy there. We'll take a look at what that looks like.
And we should read this. We read this as f of g of x. That's how we read that when we see it written this way or written this way. That's how you read it, f of g of x.
So just a little example here. To find f of g of 1, the first thing we're going to find is g of 1. So if I were to evaluate, this was my question I gave you, and I said, okay, what is that value? The first thing you would do is find g of 1. Again, sometimes it's helpful to look at this at like f of g of 1. So you want to work from the inside out. So g of 1, looking at my chart here, g of 1 was equal to 4. And then 4 will be the number that I plug into f. So that becomes f of 4, which again on my chart, f of 4 would be 8. So kind of seeing how those are linked together. So looking at my chart, another thing I can see here is that f of g of 3 would equal 12, and f of g of 5 would be equal to 16.
Okay. Oh, there's how we read it right there. All right, so caution, be careful not to confuse the notation for multiplication of functions with composition of functions. So f times g of x is not the same thing as f of g of x. Those are not the same thing. All right. All right. That's a little FYI. The order of function operations is the same as the order of operations for numbers and expressions. To find f of g of 3, you work from inside out, so you'd evaluate g of 3 first, and then substitute that result into the f function. All right, so let's take a look at an example. Let's say f of x equals 2x and g of x equals 7 minus x. Find each value. So let's start with this one. If we're going to find f of g of 4, let's work from inside out. Let's do the g of 4 first. Well, let's do this off to the side. What is g of 4? So we find the g function is right here, and we're going to plug in 4 wherever we see an x. So g of 4 is going to be 7 minus 4, which gives us 3. So now I know that this inside part is equal to 3, which means I'm really trying to find f of 3. To find f of 3, I go to my f function, and I'm going to plug in 3 for x, and so I'm going to get 2 to the third, which is 8. So our answer for f of g of 4 is equal to 8.
Let's try our second example here. We have g of f of 4. Again, starting from the inside out, the first thing I need to find is f of 4. So going back to this function for f, I'm plugging 4 in for that x value, so I end up with 2 to the 4th. Again, remember that's 4 copies of 2 multiplied together. So this is going to equal 16. So now I'm really evaluating g of 16. So in my g function, again, I'll be plugging 16 into right there. So 7 minus 16, my final answer here will be -9. So I would want to write this all together in one statement as g of f of 4 is equal to -9.
So f of g of 4 is not equal to g of f of 4.
That's correct. The order in which they are written, which you start from the inside out, is going to be different depending on your functions. All right, your second must do, we're given f of x and g of x, and again, we'd like to find f of g of 3 and g of f of 3. So start from the inside and work your way out.
All right, so let's take a look at this example. We are writing composite functions. So given that f of x equals x squared minus 1 and g of x equals x divided by 1 minus x, write each composite function and then state the domain of each. So if we want to write f of g of x, we want to write f of, well, what is g? G of x is x over 1 minus x, so we're plugging in x over 1 minus x into the f function. And so when we do that, that means wherever we see an x, like right here in the f function, this whole thing has to go in its place. So we're going to have x over 1 minus x has to be squared minus 1. So we get x squared over 1 minus x, quantity squared minus 1. And we want to state the domain for this. And so the domain would be the set of all real numbers, x, such that x is not equal to, well, what's going to make this equal to 0 here? And that's going to be if x is equal to 1. So we got to kick 1 out of the domain. So the domain here would be x not equal to 1.
And remember, if you guys are in my class, Miss Bella here, remember we've been talking about using the infinities just so you can see how that's related. That would be the same as this notation here, okay? Because I know we've been using it kind of the other direction. All right, let's try g of f of x. So again, we're going to start on the inside and figure out what is f of x. Well, f of x is equal to x squared minus 1. So that is the whole quantity I'm going to be plugging into our function g. Again, in the function g, wherever you see an x, this whole quantity needs to go into its spot. So we're going to end up with the quantity x squared minus 1 over 1 minus, now be careful here with your negative. I'm going to put parentheses here to help us out. X squared minus 1, that quantity on the bottom. If we clean that up a little bit, again, think of this as a -1, I'm going to distribute into both of these. So I will have in the numerator x squared minus 1, and on the bottom I now have 1 minus x squared plus 1. Or this is really x squared minus 1 over negative x squared plus 2. So that is our simplified version here for what we're working with. Maybe we want to scoot that over a little bit. Maybe that looks a little bit nicer.
So can we divide out these x squareds?
We cannot. Remember, the only way we could divide out is if we had factors. So if we were to factor the numerator and denominator and find something in common, then I could divide those out and reduce it.
So the x squareds there are terms.
They are, right, they are terms and not factors. So to finish this up, we want to talk about our domain. So our domain, again, we'll use the same notation here. It's going to be x, part of the real number system, such that x cannot be what value? Well, we need to, again, set our denominator equal to 0. So let's do a little solving here. What values of x would this be? Well, maybe I'll subtract 2 over. I'll divide by -1. Remember, to get rid of a square here, I'm going to square root both sides. And we know we're going to need 2 answers here. So plus or minus the square root of 2. So we have 2 numbers that we'll need to rule out. The x cannot be positive square root of 2 or negative square root of 2. Again, if you want to go back to our infinities, that's fine as well. Just rule out those same numbers for your x values there. And that takes us to the end of our notes.
All right, so hopefully you took good notes and that you did all your notes must do, and we will see you next time.